3-Eye Atlas is moving closer to the sun. There's still so much we don't know. And
there's a mysterious interstellar object hurtling towards our solar system, exciting scientists across the globe.
The revelation of new imagery by the European Space Agency ESA of the interstellar visitor known as 3-Eye Atlas has sent ripples of uncertainty through the scientific community. Early photographs captured by ESA's own Martian orbiters, the ExoMars Trace Gas Orbiter and Mars Express, show a strange, luminous blob of dust and ice hurtling through our realm. But a closer look reveals something deeply unsettling. This object did not simply drift in as a benign wayward comet. The data points to structural oddities, anomalous outgassing, unexpected trajectories, and chemical signatures so unlike typical solar system comets that a haunting question hangs in the air. What exactly is passing through our neighborhood? Before we start, smash the like and subscribe buttons for more updates. When the first confirmations arrived in July 2025 of 3-Eye Atlas's interstellar origin, there was excitement at the prospect of studying something that formed around another star. Already, telescopes such as the Hubble Space Telescope had imaged the object, showing a teardrop-shaped cocoon of dust around its icy nucleus. But as the ESA orbiters turned their Mars-bound cameras toward it between October 1st and October 7th, the images didn't conform to expectations for a regular comet. It is those images, and the implications they carry, that cast a shadow of apprehension over what some had hoped would be an innocuous scientific curiosity. Firstly, the proximity of the flyby is worth noting. On the 3rd of October 2025, 3-Eye Atlas came within about 30 million kilometers of Mars. For orbiters designed to study the Martian surface, the observation of such a faint target at that range was a challenge. The orbital cameras had to capture a world millions of times dimmer than their intended target. And yet, they succeeded in providing the closest view yet of an interstellar object by ESA's spacecraft. But what the imagery reveals raises uncomfortable questions. The coma, the glowing envelope of gas and dust around the nucleus, was clearly present, but the tail and expected directional alignment were puzzling. Observers noted deviations in the way dust was being ejected and the shape the surrounding cloud took. The composition of 3-Eye Atlas adds further to the disquiet. Observations made with the James Webb Space Telescope found a coma dominated by carbon dioxide ice, with a mixing ratio of CO2 to H2O far higher than seen in typical solar system comets. An anomaly that compels rethinking of its origin. Water leakage was measured at a rate described metaphorically as a fire hose. That means this object, though perhaps resembling a comet, is behaving in ways that differ markedly from known comets. It suggests internal structure, composition, or history that does not align with anything observed before. With the freshly released images from the ESA's Mars orbiters, the picture of this object grows murkier. The cloud of debris around 3-Eye Atlas seemed more extensive than anticipated, and the dust emission appears asymmetric, perhaps driven by unknown processes. The path of 3-Eye Atlas offers another layer of perturbation. Rather than following a gentle solar system comet-like entry, the trajectory is hyperbolic, unbound to the sun, confirming its interstellar origins. The fact that we can observe it at all is a rare stroke of luck, but given its origins, the object arrived with potential energy and a character outside our conventional catalog of comets. When the ESA orbiters snapped the images, scientists were taken aback by how the dust coma did not align in the classical tail away from the sun pattern. Some of the released frames show ejecta seemingly being pushed toward the sun rather than away, a phenomenon explored in early studies. That behavior is deeply disturbing because it suggests forces or structures at work not typically seen in cometary physics. Taken together, these imaging results raise the possibility that 3-Eye Atlas is not simply an inert chunk of frozen volatiles. It may have internal processes or structural heterogeneity far beyond the norm. Perhaps it carries exotic grain structures, unusual internal heating, or even something artificially influenced, not implying alien craft per se, but meaning that what we assume of comets may not apply. The ESA images bolster one of the more unsettling possibilities, that comets from other systems may arrive with embedded peculiarities, and that our understanding of cometary behavior may be incomplete at best and dangerously naive at worst. Another disturbing implication concerns planetary defense. While 3I Atlas is not on collision course with Earth, its arrival reminds us that objects from other star systems can and will cross into our solar sphere. For centuries, cometary threats have been considered largely within our Sun's family of objects. Now we have evidence that objects arrive from far beyond. Objects that may behave unpredictably, with compositions and dynamics we cannot fully forecast. That means that planetary defense strategies calibrated to solar system comets may be inadequate for such interstellar intruders. The ESA images underscore that we are witnessing something entirely foreign, which may call for revision of hazard models. The accelerating rate of data collection on 3Y Atlas also gives rise to unease about time windows. The images released by ESA represent a narrow slice of its passage. The object is already rushing toward the Sun to its perihelion, and by the time the community processes these unsettling images, it may have altered further or disintegrated. The fleeting nature of such objects means we must act quickly to glean information, and yet we are playing catch-up. The ESA images arrive at the moment when the object is highly active, shedding material at extraordinary rates. In that state, it may fragment, behave erratically, or release jets that could propel it unpredictably. The hazard and uncertainty here is not collision but mischaracterization. An object we cannot model may escape unnoticed or produce consequences we did not anticipate. What is perhaps most haunting about the ESA's newly released photos is the message they send about cosmic isolation. 3I Atlas, though physically distant billions of kilometers, brings with it the legacy of another system. It tells us that the boundaries we impose around our solar system are porous. We are not alone in receiving visitors. And this visitor is not benign in the classical sense of drifting comets, it carries anomalies. The images thus force a humbling realization. Our taxonomy of comets may be too narrow. We assumed volatility, tail structure, composition largely similar across solar system comets. 3I Atlas shows that nature might have far stranger cards in its hand. The ESA imagery acts as proof that the universe sends us uninvited guests whose rules may not align with our expectation. From a scientific standpoint, the implications are far-reaching. If an interstellar object can arrive with such unexpected composition and active behavior, then the building blocks of planetary systems elsewhere may be wildly different from those we have studied locally. The ESA images show that 3I Atlas might release gas and dust in directions, with intensities and with compositions that we do not yet understand. That means the models we have built, from solar system comets' interiors to their surface evolution, may lack key regimes. In that sense, the newly released imagery is not a mere novelty. It is a red flag that our cosmic neighbors might harbor materials, structures, and histories that don't conform to our textbook. Moreover, beyond the science, there is a philosophical chill in those images. We look up and see a faint dot, captured by Martian orbiting cameras, moving through our system from an alien origin. The object is silent, mindless perhaps, yet in its silent passage it suggests that our solar system's quiet neighborhood is far less isolated than once thought. The ESA images of 3I Atlas force us to confront our cosmic vulnerability, not in the sense of imminent disaster, but in the sense of unpredictability. We have no tried and true rulebook for objects coming in from elsewhere, and each such visitor may arrive with a surprise. In the event that 3I Atlas behaves in a way that goes beyond current understanding, fragmentation, outburst, altered trajectory, the implications could stretch beyond academic interest. For instance, if the object were to shed a large fragment unexpectedly, that fragment might meet perturbing influences from planetary gravities we had not considered for an interstellar body. The ESA images, by capturing the early signs of anomaly, help us anticipate this type of scenario. They serve as an early warning. Interstellar objects may not be stable or predictable, and we should take that possibility seriously. The unsettling quality of the images is that they show far more than a passive rock. They show activity, deviation, and potential for surprise. Also, the fact that such images come from Martian orbiters is significant. It suggests that the infrastructure we have built primarily for planetary science can be repurposed for interstellar visitor tracking. And yet the fact that the images still struggled to resolve nucleus features means our preparedness is imperfect. The ESA images of 3I Atlas show coma but not nucleus fine detail, meaning our observational resolution for foreign bodies is lacking. In the future, when another interstellar object arrives, we may again scramble to adapt cameras built for other purposes. The images remind us how little margin for error we have when dealing with unknowns. The fact that the orbiters were able to capture faint data at all is a testament to ingenuity, but also a reminder that the signals from such objects will often be weak, fleeting, and difficult to interpret in real time. In summary, the ESA's newly released images of 3I Atlas do more than just add another set of pictures to the archives. They change the narrative. They introduce a sense of unease. They show that when an object comes from beyond, it may carry behavior, chemistry, and dynamics we cannot immediately decode. They serve as a marker of how little control or understanding we have over visitors from the wider galaxy. And much like a ship passing through fog, this object slips through our domain. Unknown, unbound, unpredictable. As the images circulate and experts examine the data, what becomes clear is that 3I Atlas is more than just a curiosity. It is a messenger from a different planetary system, bringing with it the possibility that our cosmic neighborhood may be loaded with other such messengers, and that each may challenge what we think we know. The ESA images stand as a portrait of that challenge, a stark, unsettling reminder that we live in a much larger, less familiar cosmic arena than ever before. The newly unveiled imagery of 3I Atlas presented by the European Space Agency lays bare details so unexpected and alien that they challenge long-held assumptions about how such visitors behave. While the earlier pictures revealed the object's interstellar pedigree and its unusual outgassing, the more recent frames go further. They expose asymmetries, irregular emissions, and structural oddities that raise deeply unsettling questions about the nature of this incoming wanderer. One of the most striking aspects seen in the new images is the irregular shape of the coma and the departure from typical tail geometry. Instead of a smooth tail that extends outward from the sun's direction, the dust and gas envelope around 3I Atlas appears compressed or skewed, suggesting that its interaction with the solar environment is not behaving in the way a normal comet would. The ESA photos show portions of the cloud protruding intermittently, while other regions seem truncated or even attenuated. This level of distortion suggests either internal structural heterogeneity in the object or episodic and directionally biased emission of materials. In effect, it appears as though the object is not simply sublimating ice symmetrically, but is reacting dynamically to its changing environment in ways we do not yet understand. As 3I Atlas approaches closer to the Sun, the heating of its surface and interior is amplifying the rate of volatile release. But the released volatiles themselves refuse to conform to the patterns typical of solar system comets. Spectral data, including from the James Webb Space Telescope and inferred in the ESA image analysis, show elevated proportions of carbon dioxide relative to water ice, far beyond what our standard cometary models anticipate. One of the newly released images features a luminous jet-like plume emerging from what appears to be a region of localized friability on the surface. The emission seems to rotate relative to the nucleus, hinting perhaps at irregular spin or outburst from a confined region, rather than an entire surface sublimation front. Such behavior introduces the possibility that internal layering or stresses, rather than a uniform icy body, is dictating the outgassing. Another disturbing implication from the imagery is the apparent size of the dust cloud. The photos suggest the envelope of debris stretches farther than early estimates, potentially covering geocentric dimensions comparable to planetary scales when scaled for viewing distance. If this assessment holds, then the object's dust production is far more voluminous than typical comets entering the inner solar system. That raises the prospect that 3I Atlas carries either a larger reservoir of volatiles than expected, or that it has entered a phase of destabilization, perhaps fragmenting internally, releasing more material than a stable body would. In either case, the images indicate that we are witnessing an object in transition, not simply passing through but transforming in real time. The orbit and motion seen in the images tighten the sense of unease. The hyperbolic trajectory of 3I Atlas confirms its extrastellar origin and means it is a one-time visitor. Yet the imaging from ESA offers clues that its path through the inner solar system is far more dynamic than passive passage. Subtle deviations in its expected trajectory, deduced from the imagery combined with ground-based observations, hint that non-gravitational forces may be acting on the object. When outgassing is asymmetric, jets can act like thrusters. The new photographs capture regions where outflows seem to preferentially direct dust and gas toward the sun rather than purely away from it. This inverted behavior is deeply disturbing in conventional cometary theory because it indicates that forces other than solar radiation pressure or simple sublimation are likely at play. That means our projections of the object's motion may be incomplete, a foreign object behaving by rules we do not yet know. Even its apparent surface features, as glimpsed in the higher resolution frames, carry anomalies. While the nucleus remains too small to clearly resolve fine structure, shadows in the coma and bright spots suggest that surface fractures or patches of high reflectivity exist. Some of the images show caps of bright material, perhaps freshly exposed ice or reflective mineral linings embedded within the dust cloud. These bright patches are not arranged symmetrically. They appear offset from the rotational axis as inferred from the imaging sequence. This unusual distribution of features suggests that 3I Atlas has either undergone collisions or internal upheaval, so that its surface is not uniform but fractured. If we imagine the object as once having formed in another stellar system, then what we are seeing might be the result of billions of years of erosion, interstellar wanderings, gravitational encounters, and perhaps even catastrophic events. The ESA imagery thus presents us with an object that is not just old, but worn, stressed, and behaving unpredictably. Beyond the internal structural oddities, the chemical implications that the images bring to light are profound. Though the images themselves do not carry spectral data, their context helps point towards certain interpretations. The extent of the gas and dust halo and the unusual morphology of the ejection streams suggest that 3I Atlas is unleashing materials that do not align with typical cometary volatiles. Some of the imagery shows amber-colored or green-tinged clouds in certain filters, hinting at the presence of gases or dust grains that might be rare or exotic. The unusual glow in parts of the cloud could indicate ionized species, or reflect small metallic grains being liberated. If so, then the images are a visual sign that this interstellar visitor is composed of more than just ice and rock. It may harbor compositions or structures reflective of its alien origin. The ESA photography thus acts as a mirror to the alien chemistry within. What these images bring to the fore is also the unsettling reality that our solar system may not be as protected or isolated as once thought. To capture an external system object at this level of detail required orbiters, such as those around Mars, to pivot their instruments. That these images exist at all is testament to the readiness of our infrastructure, but also to the fact that such visitors are rare and ephemeral. The ESA frames show 3I Atlas while it is still inbound toward the Sun, while still distant enough to offer pure observational insight. We are thus afforded a glimpse of a body from another system while it is in flux. But the fleeting nature of the event means time is short, and the images remind us how little margin we have when studying such fleeting phenomena. The implications of what we see are chilling in what they might suggest about what lies outside. If 3I Atlas, which might be billions of years old and has traveled across interstellar space, can enter our region and manifest behavior so alien, then how many more such objects might traverse our neighborhood? What if some carry even more volatile compositions, or more active structural behaviors, or even internal energy reserves? The ESA imagery suggests that we should broaden the scope of readiness, not only for planetary defense in the sense of collision risk, but for a more subtle sense of monitoring objects that might behave unpredictably. The photos raise the possibility that such objects could interact with solar radiation, planetary magnetospheres, or even the solar wind in unexpected ways, perhaps altering their trajectories or releasing material that could enter planetary environments. In the pages of the cosmic ledger, 3I Atlas may now assume the role of a test case, one that forces the revision of cometary models, formation theories, and dynamical behavior of interstellar bodies. The ESA images reveal that it is an active, evolving entity. Its dust halo, jets, asymmetries, and structural fractures imply a history of cosmic travel and a present of dynamic transformation. It is an interstellar relic, but one that is not inert. It is alive in its own way, albeit in the sense of physical change, not life as we understand it. The fact that we can see the fractures and jets means we can begin to study its internal structure, but the details remain elusive. The images suggest layers, perhaps a dense core, perhaps regions of volatile pockets surrounded by insulating material, perhaps even metallic inclusions. The existential implication touches on the origin of planetary systems, of comets, and of transport of material across star systems. Could an object like 3I Atlas have once been part of a planetary system orbiting another star, only to be ejected when a giant planet scattered it away? The images of its dust cloud expanding and its outgassing beginning prematurely suggest that it may have undergone a long period of dormancy before being awakened by the sun's heat. The fact that the emission patterns are uneven may indicate that its surface was coated in layers of darker material, insulating internal volatiles until a weak point opened up, resulting in a jet plume as seen in the ESA frames. If so, this object is a time capsule not just of material, but of processes that may have occurred elsewhere in the galaxy. The images give us only a hint of this, but the implications are broad. Intercepting such an object offers the chance to study planetary formation chemistry far beyond our own system. The ominous potential lies in the unpredictability of this kind of visitor. If we have come to consider comets as largely predictable, following seasonal patterns as they heat up, forming tails, shedding dust in relatively well-understood ways, then 3I Atlas is telling us that this template may be inadequate when dealing with visitors from elsewhere. The ESA images show behaviors that fall outside that template. If we were ever faced with an interstellar object that had an eccentric trajectory bringing it much closer, or that carried denser materials or more energetic outgassing, the consequences could range from negligible to profound. The images act as a warning sign. Our understanding may be built on local system comets, but that universe of understanding may not apply when the visitor hails from a wholly different origin. In the context of planetary defense, the ESA imagery also prompts reconsideration of risk assessments. Even though 3I Atlas does not pose a collision threat to Earth, its passage reminds us of the existence of interstellar objects that may not adhere to our known behavior. The images of asymmetric jets and non-standard dust emissions suggest that trajectory changes might occur without warning. If a similar object were to enter a more Earth-proximate path, and we assumed it would act like past comets, we could be blindsided by an object that changes course, sheds mass unexpectedly, or reacts to solar radiation in ways we cannot currently model. The images thus underscore the need for dynamic monitoring systems and flexible response strategies, not only to physical impacts but to the broader category of interstellar intruders. From a philosophical vantage point, the images released by ESA evoke a sense of cosmic humility. Here is a chunk of debris from another star system, passing through our cosmic backyard, and we have captured its visage while it still retains much of its foreignness. The dusty halo, the jets, the structural oddities, they all speak to a system other than ours, a formation environment, evolutionary history, and internal composition alien to our models. The images remind us that our solar system is not isolated, that the galactic neighborhood constantly exchanges material, that the boundary between ours and others is more permeable than once thought. And if our understanding of comets, built on decades of solar system data, is incomplete when applied to interstellar visitors, then the images of 3I Atlas challenge us to rethink our cosmic paradigms. Equally unsettling is the fact that much of the object's behavior revealed in these images remains unexplained. As scientists pore over the data, the questions multiply. Why does the jet emerge preferentially from one side? Why does the coma shape deviate from expectations? Why does dust eject toward the sun rather than away? The imagery does not carry full answers, but it makes the questions more urgent. That urgency is compounded by the fact that the object is already traversing toward the inner solar system and will soon be past the optimal observation window. Each image from ESA provides a fleeting snapshot of a dynamic process in progress, one we risk losing as the object moves on. While speculations about the object's origin and internal structure will surely continue, the ESA images bring credibility and detail to that speculation. A student of planetary systems might have thought that the differences between one star system's debris and another's are minor at best. These photographs contradict that notion. They show an object shaped by different forces, with different ingredients and different structural responses. This means that when we next look into the skies and discover another interstellar visitor, we must approach it not as just another comet, but as a wild card, potentially far stranger than our current catalogs. Looking to the future, the implications of what is captured in the ESA images extend beyond academic curiosity. If objects like 3I Atlas are common, then our solar system may be receiving debris, ice-rich bodies, even planetesimals from other star systems more frequently than we once thought. The ESA images hint that such bodies may carry unique chemical signatures, perhaps heavier volatiles, more metallic content, or internal structures unfamiliar to us. Those bodies might seed planetary systems, deliver exotic minerals, or even influence the evolution of planetary surfaces through sporadic impacts. The images of 3I Atlas thus open the door to a larger reconsideration. Our solar system is not closed. In that sense, the photographs pose a deep-time question. What does it mean that material from another star system is passing through ours? Could it have once passed through? And might it again, bringing with it unfamiliar chemistry, dust grains, and perhaps even microorganic material formed under different stellar conditions? The ESA images of 3I Atlas bring to life the possibility that such interstellar exchanges are not purely theoretical, but manifest and observable. The asymmetries, jets, dust cloud morphology, and chemical hints present in the photographs are signposts of a broader, dynamic galactic process. Of all the objects we might look to as messengers from other worlds, the images of 3I Atlas carry perhaps the most vivid implications. They show that a visitor from another star system is not just passing through quietly, but is active, evolving, interacting with our sun, shedding material, changing shape, and leaving a trail of data behind. The photos thus function as a calling card, a sign that we are not in a benign, isolated bubble, but immersed in a cosmic stream of material, often unnoticed. The images raise the specter that our previously held models of comets, planetary formation, and interstellar interactions are due for revision. The ESA's newly refined imagery continues to deepen the mystery surrounding 3Y Atlas, revealing subtleties that transform scientific curiosity into a profound cosmic reckoning. Among the most recent visual analyses, astronomers have identified faint streamlines of material stretching outward from the comet's nucleus in directions inconsistent with gravitational or radiative influence. These filamentary trails appear to pulse in intervals, not continuously, as though they are being modulated by internal rhythms within the object. Such behavior has not been documented in any solar system comet, suggesting that either 3I Atlas possesses an internal thermal mechanism unlike any we've studied, or that external electromagnetic effects are interacting with it in ways previously unseen. Closer inspection of the new ESA photocomposites shows how the brightness of the coma fluctuates over time, producing subtle light curve patterns. These oscillations may correspond to the rotation of the nucleus, but the rhythm does not match predictions derived from previous measurements. The light fluctuations are irregular, implying that the object could be tumbling chaotically rather than spinning about a stable axis. A tumbling interstellar body presents a unique challenge for modeling, because each new orientation exposes fresh layers to solar radiation, triggering unpredictable bursts of outgassing. In other words, 3I Atlas may not merely be erratic. It could be in a state of physical instability, shedding mass as it loses cohesion from the stresses of interstellar travel and sudden solar heating. The new imagery also hints at magnetic interactions. As the dust and ionized gases stream away from the nucleus, they appear to twist into faint helical structures, a pattern consistent with electromagnetic coupling between the ionized gas and the interplanetary magnetic field. This phenomenon has been observed faintly in certain comets, but never with such definition. It raises the possibility that interstellar objects carry magnetic properties imprinted by their home environments, possibly remnants of their parent star's magnetic fields. If that is true, each interstellar object could serve as a data capsule preserving the magnetic fingerprint of its origin system. The implications for astrophysics are staggering. 3I Atlas might not simply be a traveler, but a messenger carrying encoded traces of another sun's magnetic breath. Another subtle revelation from the images lies in the color mapping. When the images were processed through multiple spectral filters, a faint halo of bluish luminescence emerged, surrounding the primary dust plume. This could signal the presence of exotic ionized molecules, perhaps compounds that only form under conditions different from those in the solar system. Some researchers have speculated that the glow could come from photoluminescent carbon chains or polycyclic aromatic hydrocarbons, molecules that are known precursors to organic chemistry. If confirmed, the ESA's images would mark the first direct visual evidence of interstellar organics entering the inner solar system in active form, hinting at a shared chemical continuity across the galaxy. Even the scale of what is seen challenges imagination. The processed data reveal that 3Y Atlas is enveloped in an extended cloud stretching tens of thousands of kilometers across, meaning that the small nucleus acts as the heart of a gigantic evolving storm. Within that storm, fine dust grains spiral outward in intricate patterns shaped by the object's unpredictable rotation. These swirls give the impression of a cosmic heartbeat, periodic surges of energy emitted into the void. Each pulse may represent centuries of stored energy finally being released under solar exposure, the last act of a body that has wandered through cold interstellar darkness for millions of years. Through all of this, the tone of the ESA's data release remains cautious, yet charged with awe. The images confirm that our solar neighborhood is not a sealed sanctuary, but a crossroad where travelers from alien systems may pass, leaving behind fragments of their existence. 3I Atlas, in its erratic motion and glowing asymmetry, stands as proof that the galaxy is alive with movement, transfer, and silent exchange. The disturbing beauty captured by ESA's cameras reminds us that space is not empty. It is dynamic, ancient, and forever unpredictable. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the new 3I Atlas photos ESA just revealed? We want to hear from you. Thank you for watching and see you next time.